Welcome back to the deep dive. Today, we're wading into something you really can't ignore anymore. Large language models, LLMs.
hmm
They're just, well, they're baked into so much now, aren't they? Writing tools, coding help, answering questions, even making decisions. They feel incredibly smart.
They really do.
But here's the question that, keeps nagging at me, and I think a lot of people. How much can we actually trust them?
Right.
Like when an LLM gives you an answer and then this explanation for why it's right, how sure should you be? And maybe more fundamentally, does the LLM itself even know how confident it is?
That's the million-dollar question, isn't it?
Exactly. So to really get at this, we're diving deep into a really fascinating, quite rigorous new study. Just came out in Nature Machine Intelligence, Steyvers and colleagues.
Yes, it's a significant piece of work.
And what's great is it doesn't just, describe what LLMs do. It takes this really detailed, almost forensic look at the gap. And it is often a problematic gap between the LLM's own internal confidence, its sort of hidden probabilities, and what we humans think it knows just based on the words it spits out.
And this kind of research is just crucial right now. I mean, think about where these models are going. It's not just summarizing articles or writing emails anymore. They're getting pushed into healthcare, helping with diagnoses, legal research, financial analysis, even informing policy on huge things like climate change.
High stakes.
Absolutely high stakes. So in those areas, knowing if the output is reliable isn't just nice to have. It's critical. You need to understand the dependability, not just get an answer. Can you actually use this information safely?
So, okay, our mission for this deep dive. Let's pull apart the key findings from this paper. We'll look at some, frankly, surprising ways we react to the explanations they give us, ways that might be leading us astray. And then the really interesting bit, we'll explore this novel approach the researchers tested to try and, bridge that trust gap, make the communication better.
Right. And at the heart of it all is this idea of a gap, a disconnect between the LLM's actual hidden internal confidence, its statistical assessment, and the confidence you feel based just on reading its explanation. And they identified two key types of gaps they studied.
Two gaps, got it.
First, the calibration gap. Think of it like a weather forecast. If the weather person says 80% chance of rain, and it really does rain 80% of the time they say that, they're well calibrated.
Makes sense.
So a calibration gap with an LLM means maybe you read the explanation and think, yeah, I'm 80% sure that's right, because it sounds convincing.
Right.
But internally, the model's own score for that answer was, say, only 55%.
Yeah.
That difference, that mismatch between your 80% and its 55%, that's the calibration gap. A big gap means we're consistently misjudging how accurate it really is.
We're being misled by the explanation style.
Potentially, yes. The second gap is the discrimination gap. This one's a bit different. It's about telling right from wrong. How well can you, just from the explanation, tell the difference between an answer that's likely correct and one that's likely incorrect?
Okay.
Compared to how well the LLM's internal score can tell the difference. Imagine like a medical test, discriminating between sick and healthy patients.
Right. How good is it at separating them?
Exactly. A big discrimination gap means the LLM might internally have a pretty good signal that an answer is shaky, maybe likely wrong.
But it's not communicating that.
Precisely. The explanation it gives doesn't help you make that distinction. You can't reliably separate the good answers from the bad ones based just on the words.
And understanding that contrast, the hidden internal stuff versus what we see in the text, that's key to how they set up the study, right?
Absolutely. They specifically differentiate model confidence, that internal probability score, often derived from things like token likelihoods deep inside the model, stuff you don't normally see.
The hidden number.
The hidden number. And they compare that to human confidence, which is just your gut feeling, your probability estimate, based only on reading the explanation text, just the words on the screen.
Okay, so how do they measure these gaps? Like, put numbers on them?
Yeah, they use standard metrics, which is important for rigor. For the calibration gap, they used expected calibration error, or ECE.
ECE.
Think of it as the average difference between the confidence level stated and the actual accuracy at that level. Lower ECE is better means confidence matches reality more closely.
Got it. Lower is better.
And for the discrimination gap, they used area under the curve, AUC.
AUC, right. Heard of that one.
It basically measures how well a score, whether it's the model's internal score or your confidence rating, can separate the correct answers from the incorrect ones. 0.5 is random chance, like flipping a coin. 1.0 is perfect separation.
So higher AUC is better here.
Exactly. Higher means better discrimination. Using ECE and AUC let them quantify these perception issues really clearly.
Okay, makes sense. So armed with these concepts, let's get into experiment 1. Setting the baseline right. What happens with just normal default LLM explanations?
And the findings here were pretty stark. First, a massive calibration gap. People consistently, significantly overestimated the LLM's accuracy based on standard explanations.
We think they're better than they are.
Much better, according to this. The ECE for human confidence was way worse, meaning less calibrated than the ECE you'd get just looking at the model's internal numbers.
Wow.
And a lot of this error came from people feeling very confident, assigning high probability ratings, even for answers where the LLM's actual performance was pretty poor.
So we trust the confident sound of the explanation.
It seems so. The paper suggests we generally come in with this prior belief that LLMs are highly accurate, and the default explanations do nothing to correct that, maybe even reinforce it.
Okay, so bad calibration. What about telling right from wrong, the discrimination gap?
Also not good. The study found humans were only slightly better than random guessing at discriminating correct from incorrect answers using default explanations.
Only slightly better than flipping a coin.
Pretty much. The human AUC scores were down around 0.589 to 0.602. Remember, 0.5 is chance.
Yeah, that's not great.
But here's the kicker. The model's internal confidence scores were much better discriminators. Their AUCs were up in the 0.746 to 0.781 range.
So the model knew better internally.
It had a better signal, yes. But as the paper puts it, whatever internal LLM representation is used to tell the difference is not conveyed effectively to humans in those standard explanations. The signal gets lost in translation.
Okay, so default explanations are basically failing us. They make us overconfident and don't help us spot errors. Right, this is where it gets really interesting then. Experiment 2. They started messing with the explanations.
Exactly. They didn't just identify the problem. They started to systematically poke and prod the explanations to see what features influence our confidence.
How did they do that?
Two main things. First, they played with uncertainty language. They actually wrote versions of explanations using phrases indicating different confidence levels: low, like I am not sure; medium, like I am somewhat sure; and high, like I am sure.
Explicit cues.
Explicit cues. Second, they manipulated explanation length. They generated long explanations, short ones, and versions that only had the uncertainty phrase and nothing else.
Okay, so varying the words and the length, what happened?
Well, first finding, maybe not surprising but crucial to confirm, uncertainty language works. When the explanation explicitly said, I am not sure, or similar low confidence phrases, people's confidence ratings dropped significantly.
So we can pick up on those cues if they're given clearly.
Yes, we can interpret direct statements of uncertainty appropriately. That's good news.
But. I sense a but.
But. The second finding was the surprising one. A very clear length bias.
Length bias.
Yes. Longer explanations consistently made people feel more confident than short ones. And short ones made them feel more confident than just the uncertainty phrase alone. It was a significant effect.
Wait, so just more words made people trust it more, regardless of the actual content?
That seems to be the implication. And here's the really critical part. The extra information in the longer explanations. It didn't actually help people get better at telling right answers from wrong ones. Their discrimination didn't improve with length.
So longer felt better, but wasn't actually more useful for accuracy judgment.
Exactly, which points towards, as the researchers say, a shallow level of processing. We seem to be using length as a simple heuristic, a shortcut. Longer equals more effort equals more credible.
Huh. That feels uncomfortably human. We do that, don't we? Assume detail equals accuracy.
It aligns with a lot of psychological research on persuasion, yeah. Length and detail can be persuasive even if the substance isn't solid.
Okay, so standard explanations have big gaps. Uncertainty language helps if used, but we get fooled by simple things like length. Is there a way to actually fix this? To make the LLM communicate its true confidence better? This is where the study got innovative, right?
Yes, this is the core innovation, the really novel contribution. They proposed and tested a way to create tailored explanations.
Tailored how?
The central idea is simple but powerful. Explicitly link the LLM's hidden internal model confidence score to the style and language of the explanation it generates.
Ah, so if the model is internally not very sure, it should say it's not very sure.
Precisely. Instead of always defaulting to a confident-sounding detailed explanation, the way it explains itself changes based on its internal probability assessment for that specific answer.
Okay, that makes intuitive sense. How did they test if that actually works?
They used a clever simulation approach. Remember experiment 2 showed how humans react to low, medium, and high confidence language styles?
Right.
They used those results to build what they call the selection rule. Think of it like a translator. It takes the LLM's internal confidence score for an answer. Let's say it falls in a low confidence range based on its number. The selection rule then tells the LLM, okay, for this answer, generate an explanation using that low confidence language style we tested in experiment 2. If the score was high, it uses the high confidence style.
So it matches the output style to the internal state based on how humans were shown to perceive those styles.
Exactly. It's bridging the internal state and the external perception using the experimental data. They then simulated what user confidence and discrimination would look like if LLMs consistently use this tailoring approach.
And what did the simulation show? Did it work?
It worked remarkably well, according to their analysis. The calibration gap narrowed substantially. Human confidence in this simulated scenario became much better aligned with the LLM's actual accuracy. People weren't being systematically overconfident anymore.
That's huge. We get a more realistic picture.
A much more realistic picture. And secondly, the discrimination gap also narrowed significantly.
So people could tell right from wrong better too.
Yes, because the style of the explanation, the confidence language used, was now a much more reliable signal of the model's underlying certainty. The tailored language effectively communicated the uncertainty that was previously hidden.
Wow. Okay, so that's the key innovation then. Explicitly linking the internal probability to the output language seems like a really promising direction for designing more trustworthy AI.
It really does seem to be a powerful mechanism. But, there's always a but or nuance in research like this.
Ah, okay. What's the catch?
Well, the tailoring helped people understand the LLM's confidence much better. But the study also highlighted a limitation on the human side. In the task they used trivia, general knowledge questions, the participants themselves often didn't have enough independent knowledge to actually judge if the LLM's answer was ultimately right or wrong, even when they knew how confident the LLM was. Meaning, when they gave people the chance to change the LLM's answer after seeing the tailored explanation, people weren't necessarily very good at correcting it if it was wrong. Their own accuracy in trying to fix the LLM's answers was often similar to or even worse than the LLM's accuracy.
So knowing the LLM is only 50% sure doesn't help you find the right answer if you also don't know the right answer.
Exactly. Better communication of uncertainty is crucial, but it doesn't magically grant the user domain expertise they don't have. You still need some independent knowledge to effectively use that uncertainty information to improve the final decision. Even people who rated themselves as experts didn't necessarily do better at correcting the LLM.
That's a really important point. Okay, so that raises this other fascinating question they brought up. Why do LLMs produce these badly calibrated explanations by default? If they have some internal sense of confidence, why doesn't it come through naturally?
Right, well, the default disconnect.
Yeah.
They hypothesized two main reasons, and both are really interesting insights into how these models work. First, RLHF bias, reinforcement learning from human feedback. That's how many models like GPT are fine-tuned based on humans rating which responses they prefer.
Right, making them helpful and harmless.
Helpful, harmless, and perhaps overly verbose and confident. The hypothesis is that because humans prefer detailed, well-structured, longer explanations like the length bias showed, the RLHF process might inadvertently train the models to produce explanations that look good and sound confident because that's what gets the positive human feedback, even if the underlying answer is uncertain. It's optimizing for perceived quality, not necessarily for accurate uncertainty expression.
So we're training them to be convincingly wrong sometimes.
That's the concern, yes.
Yeah.
The second hypothesis is linked to their autoregressive nature, and so they're called choice supportive bias.
Autoregressive means word-by-word generation.
Exactly. They generate text token by token. The idea here is once the model commits to the first few tokens of an answer, the rest of the generation process, the explanation part, might become biased towards generating text that strongly supports the answer it already started giving.
Ah, like cognitive dissonance reduction. Once you've made a choice, you convince yourself it was the right one.
Precisely. It's analogous to choice supportive bias in psychology. The model chooses an answer, then its explanation generation process might implicitly work to justify that choice, making the explanation sound more certain than the initial internal assessment might have warranted. It's constructing post hoc confidence.
Wow, these models are inheriting our psychological biases. That's both fascinating and a little unnerving. These are really powerful potential explanations for the default gap.
They really are. And they highlight that fixing this isn't just about adding a feature. It might involve rethinking aspects of training and generation.
And just quickly thinking about how they did all this, the methodology seems pretty solid.
Yes, it was quite rigorous. They tested multiple major LLMs, GPT 3.5, Belem 2, the newer GPT 4.0, across different question types, like multiple choice from MMLU and short answers from Trivia QA, to make sure the findings weren't just specific to one model or task.
Good coverage.
And they were careful about measuring confidence, using token likelihoods for the model's internal score, which is a standard approach, and then specific behavioral experiments for human confidence, asking people for probability estimates based only on the text.
Isolating the effect of the explanation itself.
Exactly. And the overall structure was key. Experiment 1 set the baseline problem with default explanations. Experiment 2, systematically varied explanation features to understand human reactions. And then the innovative part, using that simulation with a selection rule to test the proposed solution, the tailored explanations. That multi-step approach lets them build a strong case.
Right. That careful design makes the conclusions much more convincing. Okay, so let's try and wrap this up. What's the big picture message we should take away from this deep dive?
I think the biggest takeaway is the critical, urgent need for better uncertainty communication from LLMs. The default just isn't good enough.
Right.
It leads us to overestimate their accuracy and makes it hard to know when to be skeptical. That's a real problem as they get embedded in more critical decision-making loops.
But the encouraging news, the design insight here, is that tailoring works. If we can make the LLM's language reflect its internal confidence, we significantly improve things for the user. Better calibration, better discrimination. That's a concrete path forward.
Definitely a key principle for building more trustworthy AI. But we also need to remember the human element. Better AI communication doesn't automatically solve for lack of user expertise.
True.
And those potential underlying causes, the RLHF bias, the autoregressive effects, they suggest we need ongoing research into the core behaviors of these models, not just surface-level fixes.
It really drives home that building reliable AI partners isn't just about making them factually smarter. It's maybe even more about making them better communicators of their own limitations, of what they don't know, making that internal state clear.
Absolutely. And that leaves us with a really interesting, maybe slightly challenging final thought for you to ponder. As these LLMs get even more complex, potentially more opaque inside, will we be able to keep pace? Will innovations like tailored explanations allow us to maintain a clear understanding of their internal confidence? Or will the gap between their hidden state and our perception just become a permanent, maybe even widening challenge in the human-AI relationship? Something to think about next time you get a very confident-sounding answer from your AI assistant.
A really crucial question for the future. Thanks for joining us on this deep dive into LLM confidence and human trust.